Hey everyone, I'm going to do a video on systems of equations. We're going to do solving them algebraically in this video. Obviously solving graphically, you would just graph the two functions and see where they intersect. So algebraically though, you need to use different methods in order to find x and y. So the first method I'm going to show you is just setting the equations equal to each other. So if you notice, both these equations are equal to y. Now because they're both equal to y, they have the same output, which means that they would result in the same answer. So because that is true, you can set both of these things, these two things, equal to each other because they would have the same result. So x squared minus 11x minus 36 can be set equal to negative 12x plus 36. Also, this is a systems of equations with a parabola that is upward, and a line that has a negative slope. The reason why I know that is because the highest exponent here is 2, and this is y equals mx plus b, and it's a negative value, so a negative slope. When I solve for this, I'm just going to solve like I normally would. So if you remember, x squared likes to be positive and equal to 0. In this problem, he is positive on the side that he's on already, so I'm not going to move him, but I'm going to move these pieces of information over to the left side towards the x squared so that it's equal to 0. So I'm going to add 12x, canceling this out, and subtract 36. And cancel that out. I'll get x squared plus x minus 72 equals 0. Now to continue to solve for this, you're just going to factor. In this case, this is am. It's add and multiply because the a value here is 1. So I'm going to have different signs, plus minus. The reason why I have different signs is because the last sign is negative. The factor 72 that add to 1 will be 9 and 8. This will get me the values of x equals negative 9 and x equals 8 because they're both being set equal to 0. Now the last thing you need to do is find the y values that go with these x values. In order to do that, you're going to plug it into the linear equation, which is negative 12x plus 36. You can plug it into the quadratic. Because it's a systems of equations, they're working together, and that's the definition of a system of equations. They're two equations working together, so they will cross at the same value. So it really doesn't matter which equation you plug into. I usually choose the linear one because it's easier to plug into. So I'm going to plug in negative 9 into the linear, so it'll be negative 12 times negative 9 plus 36. That'll give me a y value of 144. So my first coordinate point where the two systems intersect will be negative 9, 144. To get my next y value, I'm going to do the same thing, but plug in 8. My result here would give me a y value of negative 60. So my next coordinate point where the parabola and line intersect would be negative 60, 8, negative 60. And there are my two answers. So basically what's happening here is you have a parabola and a line that's negative, and they're crossing at two values here. The next equation is also a line and a parabola. The only thing different here is that notice that this equation is not equal to y. Now you can go ahead and set it equal to y and do the same thing we did in the first example, but I'm going to show you another method called substitution. What you'll do is you'll take this piece and put it in for the y value. Because this is equal to y, that means it has the value of y here, so I'm going to put this inside there. This is called substitution. So I'm going to have x squared minus 6x plus 9 in for the y. I'm going to have this plus x, because that was here, equal to the 5, because that was here. Okay, so now I'm going to solve like I normally would. On this side, I notice that I have like terms, so I'm going to combine that to be minus 5x plus 9 equals 5. Again, like the last problem, x squared likes to be positive and equal to 0. It is positive on the side that it's on, but not equal to 0. In order to make it equal to 0, I'm going to subtract 5, and I'll end up with x squared minus 5x minus positive 4 equals 0. And now I'm going to do the AM method again. X and x. I'm going to have the same signs because the last sign here is positive. What are they? They're both negative. Factors of 4 that add to 5 would be 1 and 4, giving me the two x values of the intersections to be 1 and 4. So again, we have a parabola and a line, and in this case, I have a parabola and a line intersecting at two values, at 1 and 4. I just need to find the y values. And like the last one, we're going to use the linear equation. The linear equation is y plus x equals 5. So I have y plus 1 equals 5. If I solve for y, I'll subtract the 1 to get a y value of 4. So my coordinate point for x equals 1 is 1, 4. To get my y value here, I'll do the same thing. So y plus x equals 5. Again, this is the linear equation they gave us. So if you look at the top, this is the linear equation right here. Okay. I'm going to plug in the 4. So y plus 4 equals 5. Subtract the 4. That'll get me y equals 1. So my other coordinate point where the parabola and line intersect is 4, 1. The next question is slightly different just because there is a fraction. There are two ways to do it. Either you could plug this in for x squared in x, but I would avoid that just because you're going to have fractions inside of here. And normally we also solve for x, so it's probably better off that we plug this in for y using substitution again. So I'm going to put that in here. That doesn't mean to say that you can't solve another way. This is only one method out of many, but the way that I'm going to show you in this video is I'm going to substitute that y value in for the numerator on this fraction. What I can do now is multiply either side by 3, and these will cross out. Now you could also, instead of doing that, you can put this over 1 and cross multiply, getting 3x equals x squared plus 9x minus 91. Now both methods of multiplying by 3 on either side and cross multiplying still get you the 3x and then the x squared plus 9x minus 91. Okay, so like in the previous examples, we want 3x to be moved over here so that x squared becomes equal to 0. So that gives me 6x minus 91. Now, if you can't think of the factors of 91 that add to 6, go to your y equals and type in 91 over x into the y equals and look at the table. When you do that, you'll see that the factors that add to 6 with 91 are the values of 7 and 13. And I'm just going to change this up here because I actually have them in the wrong places. I want a positive 6. This should be the 13. That should be the 7. So I have x equals negative 13 and x equals a positive 7. Again, in order to get my y values, I'm going to use the smaller equation, the simpler one, which is this one over here. So this one here is the easier equation, and I'm going to pull that down here just to show you how I'm going to deal with it. So it's x equals y over 3. Now I know that x in this case is negative 13. That's equal to y over 3. To get my y value, multiply by 13. Well, 3 on either side, and that gives me a y value of negative 39. So my coordinate is negative 13, comma negative 39. And I'll do the same thing over here. So 7 equals y over 3. Cross multiply, that'll get me 21 equals y. So my next coordinate is 7, comma 21. In the last example, I have a circle and a line. The reason why I have a circle here is because it has both the x and the y squared. And this is a line. If I solve for y, I would see mx plus b. And actually, that's what I'm going to do here because the only way to really solve for a line and a circle is having one thing equal to y, and then we're going to use the method of substituting this in for the y. So I'll have x squared plus 7 minus x all squared equals 25. Okay, so I'm going to go ahead and factor this. Well, multiply it out. I'm going to use the box method here. You could also FOIL, which is what I prefer, but box is fine. I'm going to get 49 here, minus 7x here, a minus 7x there, and a positive x squared here. I'm going to bring down this x squared. I'll end up with a 49. These are like, so negative 14x plus x squared equals 25. I'm going to combine some like terms and also put this in standard form. So these are like, getting you 2x squared minus 14x plus 49 equals 25. I'm going to subtract the 25 because x squared likes to be positive and equal to 0. And I'm going to go ahead and I'm going to factor this. So now, always the first type of thing that you want to think of for factoring is GCF, and that'll actually make my life easier in this problem. So I'm going to pull out a 2. And then I can go ahead and do AM. X and X. I want same signs because it's positive, and they're both going to be negative. Factors of 12 that add to 7 are 3 and 4. Bring down the 2. Everything will be set equal to 0. So this actually 2 can never be equal to 0, so it's not really doing anything. But x is equal to 3 and x is equal to 4. So I'm just going to find my y values. And I'm going to do that by using the easier equation. So if I look up here, the easier one was the second one. And I already set it equal to y. If you notice, I set it equal to y right here. So I'm going to pull that 7 minus x down here. So in this case, if I do 7 minus 3, I get 4. So 3 comma 4 is a point. And if I do 7 minus 4, I get 3. So 4 comma 3. Okay, I hope this video helped you on systems of equations, and I'll see you guys soon.